Hi, this is Tim here. This is lesson number 8. We're going to cover, we're going to create a caster project. This is the drawing of it. What are the new things we're going to complete in this project? We're going to use hardware. We're going to create an actual assembly of parts. We're going to do a rendering of the assembly, and then we're going to create an exploded assembly. So this is sheet number 1, and this is sheet number 2. Now we're going to have a week to do this project, and next week, the week that you come back, I want sheet number 1 and sheet number 2 completely finished. Okay, so I'm going to go through a lot of this in this video, so you have no excuses. First thing you want to do is create a directory called caster project, and let's have a look. What are the parts? We have a bracket, we have a base, we have the, what is this called, the roller, we have bushings, we have the shaft, and then we have all this hardware. Now the hardware is going to be downloaded from McMaster Car, so we may as well start with that. Okay, so let's, I don't know, do I want to start with that yet? I think let's start with something simple. We'll start with the roller base, part number 1. Okay, so let's have a look at this, the roller base. So the best thing to do is, hopefully you realize that we need to create this sketch here and just extrude it. So you will see that these parts are a lot easier than what we've been doing. The main learning objective, is for you to practice assembling. Okay, so it's in, let's check this again, it's in inches, so let's give it a lash. Let's create a new part. I see inches down here. I'm going to create a new sketch. I'm going to just put this on the front plane, and I'm going to draw the origin is going to lie right bang in the center of that line there. So what is it? 4.75 by 3. And it looks something like this. That's the midpoint. Lovely. I locked that in already. No. There we go, midpoint. And what does it look like? It looks something like this. Alright. .75 in length. So what'll I do? I get a center line going, and I'll go you, and you. I'm going to make them symmetrical. And we'll make this from there to there 4.75. Easy. We'll let this line and that line be collinear, that line and that line be collinear, and let's have a look at the heights. The height of this entire object is 0.625, so from there to there is 0.625. And let's make this line and that line collinear, and that line and that line collinear. Now these height differences, I remember from seeing them, are 0.125, and that's 0.125. Okay, and then this length here is 2. So let's go back and make that line, the center line, and this other line, we make them symmetric. And what are they? 2 inches from line to line. It all goes black. Let's tidy up our dimensions a little bit. Okay, it looks good. Let's exit out of it, and we now make sure you go mid-plane, and it's a mid-plane of 3 inches, and that's it. That's the first main feature. Easy. Now, too easy for you. Radius of 0.5, 4 fillets on the edges. So let's get that. Like so. Okay, radius of 0.5, and then what's next? We need to have a 1/4-20 tapped hole, and that 1/4-20 is concentric with those fillets. A 1/4-20 tapped hole, okay, and it goes all the way through. I click on the face, and then I go to hole wizard. Now what is it? Is it a counter bore? No. Countersink? Through hole? No. It's a straight tap. Now we want ANSI inch. A quarter 20 comes up. Positions. I'm going to go look at it straight from the top. This seems very, very small. A quarter 20. Okay, that's what it is. Tiny. Who designed this? Alright. A quarter 20. So I'm just touching, hovering over the edge, just to get that center point, that concentricity. And that's it. Very, very small. That must be it. Okay. Alright, quarter 20. I would have thought it'd been a bigger hole. Alright, and end condition is through all. We just wanted to go straight through, drill and tap it, and then you're left with these holes. Now, people always ask me, well, they don't look like threaded holes to me. I'll show you what you can do. You can go Tools, Options, Document Properties, Annotations, Dimensions. Let's have a look. Detailing, Shaded Cosmetic Threads. Alright, and go OK. And look at that. There you go. Now they look like threaded holes. What they do is by default they just turn that off because it slows it down. It really doesn't that much. Now, let's save that part, and we're going to save this as in the proper folder. We'll save it as caster base. Okay, I'll close this down. Let's go on to the next one. Alright, let's do the bracket. Now the bracket. The first thing we should do is draw out this little base. I will extrude it 3 inches, and then we'll get the rest of it. So let's just draw this first bit of it out, and what will we do? We'll just make the origin that bottom right hand corner. It really doesn't matter. You could do it there, you could do it anywhere. I'm just going to make it right here. Okay? New part. I'll create a sketch on the front plane, and I just go like this. Alright, what is it? It's 1.375. 1.375, and then we have the height is a ½ an inch, and then a quarter of an inch and a quarter of an inch. Alright. 0.5, 0.25 here, and 0.25 there. Goes all black. Let's tidy up our dimensions. Very nice. Mid-plane extrude. And let's see how much we need to do it by. 3 inches. But there's that, the base. Okay, now let's have a look. Let's just close this down here. Alright. Now, on this wall, I want to draw the circle and I don't know what you call it, this supporting wall. So I'll create a sketch on this face. Let's look at it dead on. Let's get the circle going. I'll make that point and that point vertical. And let's get our quadrant lines going all the way down. Alright, and let's close the region like so. Now, diameter 1.25. Diameter 1.25. Look, we may as well put this other circle in as well, ½ an inch. Diameter 1.25. Now what's going on? Can I move that? It wants to move up and down. Let's get another circle right in the middle. 0.5. And what's the height? The height is 2.5 from the very bottom line up. 2.5. It goes all black, we're in business. Let's rotate this and let's have a look. We need to extrude it 0.3 back in this direction and then 0.2 out in this direction. So let's get the 0.3 done. So I get into my selected contours, and we'll in one direction we'll go 0.3. Very nice. There's that. Let's right click on it, turn it on, we'll share the sketch, and I'll go extrude. Let's get access to the sketch, and then selected contours. And what is this? 0.2. And let's turn the sketch off. That's probably the best way of doing that. The quickest way of doing both of those features is using a shared sketch, extruding it in one direction and then extruding it in the other direction. I apologise if I'm going a bit fast. My feeling is you should kind of know this stuff now at this stage. This should be pretty basic. Now, there's a rib here that supports that wall, a triangular rib. So which plane do we need to put this on? The top, right, or the front? Hopefully you're saying it's the front plane because you're right. So we'll create a sketch on that front plane. I'm going to click this edge, and I'm holding down the control key to select multiple ones, and I'm going to go convert entities, and I have those lines now, and all I'm doing is I'm just connecting a line from there to there, and then I'm just going to, don't trim it just yet. I actually can't trim it. What am I saying? Let's trim those bits away. Now what's the height? Did I put the height in? 1.75 from the bottom, so it's going to be from there to there, it's going to be 1.25. Like so. Alright, now what's the thickness of this rib? It's 0.5. 0.5, and I'll do a mid-plane extrude like so. Now the last thing is, I'm pretty sure there's 2 fillets and then we have 2 countersink holes. Okay, now we have to watch the dimensions of those countersink holes, so let's just put the fillets in first. Now what's the radius? I'm guessing a ½ an inch. Yep. Fillet 0.5. Alright, there's that. Let's create a click on the face and then click on Hole Wizard, and let's look at it normal to, and we want a countersink hole. Now it's a countersink hole from a 1/4 screw. Now this isn't threaded, it's just we need it's to fit a clearance fit for a 1/4, and it's 82 degrees. So really all that matters is we're looking at a 1/4 inch. Now, so we'll get our countersink. You know there's 2 angles, 100 for sheet metal and 82 for everything else. Now we want this to be a 1/4 inch size. We want it to go through all. So let's look at the positions. So I'm just going to put one in there and put one in there, and I'm going to get a center line from there to there, and I'm going to make these 2 points symmetrical. Now the dimension between the 2 of them is 2 inches. So that's nice and centered there, and then what is it? It's 0.88 from that front face. So we'll have 0.88. How did that come out? Just to be perfect like that. 0.88, and then both lines both points are black. Let's build it, and now we have our lovely countersink holes. Now what are we missing? That's it for the bracket. Okay. Now I don't know, did I make materials? Did I talk about materials in this? I didn't, so I'll have to talk about that later. Okay, so what do? We save this as caster bracket, and that's the second part. Not too hard, huh? Okay, then what's the last one? We'll do I'm going to take a break for a minute. I'm going to move on to the roller, and then I'm going to move on to the bushings. So I'll see you in a sec. I'm back. Let's have a look at creating the roller now, part number 4. Hopefully you'll realise we can just draw half of this shape and we're just going to revolve it. It should be pretty easy. Okay, so let's create a new part. And I'll do what I normally do at the start. I'll get 2 center lines. Okay, and I always draw them away from the origin and then bring them in. It's a little bit easier. Now, what does this thing look like? I've drawn this thing so many times. I'm not that close. Excuse me now. Oh my god. Okay. Let's move this thing in a little bit more. Oh my god. Something like that, I think. Am I right? I think so. Alright. Now what can we do? I'm going to make this line and that and that. I'm going to make them symmetric. This, and this line symmetric. These 3 lines, same again, symmetric. We'll make this point and that point, we want them horizontal to line up. This point and this point horizontal. This point, that point horizontal. Alright, now let's have a look. Some dimensions. Okay, so 1 inch is the bore hole. We put that in. Let's have a look. 1.75 from there to there. Sorry, I'm going a bit fast. 1.75 from there to there. The fact that I started with a sketch, then I added the relations, and I added all the symmetric relations. It makes it much easier when you actually go to dimension the part. So I think it is a good step. So, excuse me. I'm tired of this cold weather. Alright. 1.5 and then, sorry, 1.75 then 1.5. Alright. Now what's next? Diameter 1.5 from point to point. Alright, let's tidy up the dimensions a bit. What's this center one? This is 0.6 for that center beam. So from that line to that line is 0.6. Very nice. Okay. What else do we have? 1.8 from that point to that point. So you draw it across the center line, it makes it an awful lot easier. 1.8. What's the large dimension? This is 3.48 from that line to that line. .48. Very nice. Let's just drag that down there like so. Alright. 3 inches from that point to that point. Now let me look at that again. 3 inches from the inside, okay. So from there to there is 3 inches. And then what else have we got? We have this 1.125. It's just this little distance here. 0.125, and everything goes black. We've included all our dimensions. Now what can we do? Let's tidy this up a little bit. I'm going to drag that center line down a little bit to there. Bring these dimensions a little bit closer. Right, like so. Right, that's my sketch. I'm going to get out of it. I go to Features, Revolve, and I'll just revolve this contour across that axis 360 degrees, and that's my wheel, caster wheel. Alright, we'll save it, and I'll go caster wheel. Now you're probably saying to yourself, he's not applying any materials or anything like that. I'm going to do that now in a second. Okay, what's next? We have the wheel. They call it the roller, so let's go back and fix this. Caster wheel, I'll right click, and we call it caster roller. Alright, now we have the roller, we have the base, we have the bracket. Let's do the bushing. So I'll go new part, sketch. It looks something like, the roller looks something like this. When I revolve it, okay? So let's put in some center lines. Now the origin is going to be the center of this rotation. So let's have a look at some dimensions here. So 0.75 from there to there, and then 0.9 from there to there. I can remember that. 0.75, and then from that line to that line is 0.9. And let's bring this a little bit closer. Now it's a diameter of 1.25. Okay. Not that. Let's try that again. From there to there, 1.25. Okay. We need to drag all of this down. There we go. 1.25. Now what's this bore diameter? It's diameter 0.675. Okay. 0.675. Now in this it looks like we're missing a I need to know what the dimension is from there to there. Now we know this fits inside the roller, and that roller is 1 inch. So the dimension from there to there is 1 inch, like so. Now that's it. That's the bushing. Simple enough. Now, just on a side note, let's look at this thing for a sec. The bushings fit inside the roller of the wheel, and then the shaft runs through the bushings. Now, it would be nice if we could have ball bearings in there. That's kind of a bit expensive, but a bushing will do the same job. It will decrease friction. Typically, a bushing is made out of bronze, is what it's made out of, or maybe a very, very hard plastic. But you know, so we want to. So the shaft would be made out of steel. If we had steel bushing, steel on steel would be very, very high coefficient of friction. So what we want to do is we want to have a bronze on steel, which is a much lower coefficient of friction. So what do these things do? They're called a bushing. They lower the friction. Okay. I'll talk about that in a bit more in class. Now, we don't extrude this. We want to revolve it. So the axis of revolution will be this axis I put in, and then that's it. So that's the caster bushing. Right, I've saved that, and let's look. What's the last main part that we have to draw is the shaft. Now the rest of the parts we'll download. Now what does the shaft look like? Very simple. I'm drinking my morning coffee here as well. Alright, we'll create a sketch on the front plane, and I'm going to put in a center line off the bat. Make it midpoint. Do the same with this. Alright, let's get a line going. Now this shaft has a shoulder. Now why does it have a shoulder? And what the hell is a shoulder? This is a shoulder right there. The reason why it has a shoulder is this half-inch diameter. That fits inside the bracket. Okay? You'll see what I mean. So this half an inch will sit right inside that bracket there, and the bushing will sit on the main part. So let's go back and have a look. Oops, let's just leave that there. So two diameters, 0.675 from there to there, which is for the bushing, and then a half an inch. So let's just do that. 0.675, it's 675 or 625? 675, okay, we leave that there. And we need to add some constraints pretty quickly, or this thing is going to get messy. Alright, so I'll make this line and that line symmetrical. I'll make this, this, and this symmetrical. What else do I need? I think that's it. I'll make this line and that line collinear, and then we have a half an inch across the center line. Now what's the length of this shaft? The length of the shaft is 3.1. The total length 3.1. And then at the corner of my eye I saw the dimension from there to there is 2.1. Well, let's check it. 2.1, yep. And then I need to close this region, so let's put in that line there. And then I'm ready to look at this. I bet you this thing is going to revolve right off the bat, and it doesn't. Alright. Okay, we got that. That's the first revolve. Now it looks like there's some chamfers there at either end. 45-degree chamfer, 50 thousandths of it is 0.05 to help with the assembly. So, chamfer, 0.05, 45 degrees, one there, one there, one there, and one there. Now, if you look at this drawing, it looks like there's a screw that holds that in place. So there's a washer, a screw, and it screws right into that shaft. So let's have a look. So what is the hole that's in that shaft? A 1/4-20 tap. It's 0.75 deep. So what do? I click on the face, hole wizard. I don't want to countersink it. It typically does the last hole that you do. We want a threaded hole, a 1/4-20. We want a 0.75. We want the thread to be 0.75. So we'll make the hole thickness about 1 inch, hole depth about 1 inch, and the thread depth about 3/4. And I'll put this hole in like so. So there's one on that side. I'll do the same on this side. Click on the face, do another hole wizard. Because they're not on the same face or the same plane, they have to be separate features. I could also mirror it if needs be, but the hole wizard is just as quick. That's it. Now how do I turn on? I can't see my threaded holes. I'd like to see my threaded holes. So how do I do it? Options, tools, options, document properties, detailing, shaded cosmetic threads. There it is there. Now look at it. The hole depth is a lot deeper, but the threads can only go so far. Okay, so you can never have 100% threads in a hole. So that's it. Save as caster shaft. Okay, that's it. Now we've all the parts. What are we missing? We're missing the pan head screws, we're missing the flat head screws, and we're missing the washers. So let's have a look. So there you go. I'm going to just highlight. I'm lazy, so I'm just going to highlight the first part number. I'm going to go to Google. No, I'm not going to go to Google. I'm going to go to MacMaster Car. What am I doing? And all I do at the very top is I put in the part number that I want and I press enter. And that's it right there. It's a 1/4 20. It's a flathead screw and it's 1 inch in length. And I click on product detail. Now what I should have done is let you search for those parts, but I've given you the part numbers there. So let's go back here for 1 second. There it is, beautiful looking screw. Now we can have this as a drawing like so, or we can have it as a 3D part. Now let's have a look at some of these things. Because SolidWorks is such a great program, it's one of the downloads. You don't see anything else there, it's actually SolidWorks. Now we could have a 3D step, or we could have a 3D edges. Now the 3D step is a general file format. And what do I mean by that? I mean that it can be used by nearly every CAD program. It's just a general file format. It means all Inventor, Pro Engineer, SolidWorks, they can all open it. But we have SolidWorks, so let's just go with it. So I'll save it, and what it does, whoops-a-daisies, it gives me the part right there. So I'll just minimize all of this and go back, and I'll just drag this into my directory. Okay, and let's go right click, view, extra large icons. We have a screw and we have all our parts there. So I'll just go right click and let's just do small icons. Now we have that one done. Now let's get the next one going. And I'll just put the part, copy and pasting it, put the part number in up there at the top. And what is it? It's a zinc yellow chromate plated steel. It's just a washer. And I was just thinking there for myself, I'd have to draw this out, and that would would annoy me. I'd rather just get a part, to be quite honest with you. So we save it, and I'll drag it in to the to the caster. There it is. Now we have the washer. The next one is the pan head screw. Alright, that's it, that's the part number. If you buy 100 of them, if you buy a pack of them, you get 100 in it, and they're roughly $10. What type of screw is it? 1/4 20. What's the length? 3/4. And that's it, that's what it looks like. And we'll save this part. And I'll just drag it in. Alright. So view extra large icons. We have the pan head, we have the flat head, we have the washer, we have the base, we have the bracket, we have everything. We're ready to go. We can close down McMaster Car. And let's start with an assembly. So let's start our first assembly. So I'll go new, assembly, and I'm just gonna, this thing opens up here. I'm just gonna close this, it doesn't matter. You can either get your parts there, you can just go to insert components. Now I'm going to go browse, and it's very nice, it opens up this directory. Now what should be the first part that I install? Some of you are probably thinking the roller, some of you are probably thinking the base, and if you're thinking any of the other things, you're probably not right, but you could make it work. The base is the first thing to do. So hold on for one second. I'm going to do that again. File, not a new part. What am I doing here? Let's do that again. File, new, assembly. Okay. Browse, base. Alright. I'm just going to put it in anywhere. I'm just going to click anywhere. Okay. Now let's look at a few things here. The first thing you see is we don't have a feature tree here anymore. This is an assembly tree of parts. So we have an assembly, and we have the first part we brought in was the caster base, and I can rotate and I can do my normal stuff around here. And notice that it has an F beside it. That means that the part is fixed in space. If I try and grab that, or I try and move it, it says the selected component is fixed, it cannot be moved. So let me show you. I'll right click and I'll go float. And now I can move that in 3D space. It's just moving around the place. Okay? Now, the first part you bring in is always going to be fixed. And the other parts will move relative to this part because it's fixed. Now, when I first started doing SolidWorks, I would just throw in a part and I would fix it and then I would start assembling around, but it's not a very good habit. I'm going to show you what I want you to do. So you bring the part in and it's fixed. You're going to right click and you're going to go float. Now let me just show you. Now I can move this around. Now I'm going to open up this plus button here and I have a front, I have a top, and I have a right plane. Now they're the part planes, the front, top and right. Notice that the assembly also has a front, top and right plane which are right there. So what we should do is, let me just show you where they are. I'm going to turn them on. There's the front plane. Now I'll go up to view and turn on the plane so we can actually see it. These are the main planes for the assembly. Now what I'd like to do is I'd like to mate the planes from this part with these planes, and you'll see what I mean. So I'm going to mate this front plane with that front plane. So watch this. I click on mate. Now don't worry about this for this business here for a minute. All I'm going to do is I'm going to click on the front plane. Now notice how I opened up the feature tree to get access here, or the assembly tree really is what it is. So I'm going to make these two front planes and look what happens. Okay? And then I'm going to mate the top plane of the assembly with the top plane of that. Now watch this. I can grab that and I can move that part now just in one plane. I hope you're not getting too confused now. So what are we missing? We're missing the right plane. So I'll mate the right plane with the right plane. Okay, now what's happening? I'm after lining up my part planes with my assembly planes, and my part can't move because it's fixed in space, it's fully defined. So now I'll turn these planes off. Now if that didn't make any sense at all, you can just right click on it and you can go fix. Okay, and it's fixed in space. It's not, it works, but it's not a very good habit. Now I'm after doing 3 mates, plane to plane mates right there. Okay, and there they are. So there's the first part I have is there, and at the very bottom are the mates. Now watch this. I'm going to go insert components. I'm going to hit the pin, and I'm going to go browse. And I'm going to browse for 2 brackets. I'm going to put one there and one there. And now I'm going to really get into mates, and you'll see what I mean. So forget about him for a sec. I'm going to mate this face to that face, and it's going to be a coincident mate. It does it automatically because there's really nothing else you can do. What does that mean? Now I'm after applying that mate, and look, I have 4 mates, and if I click on one it tells you what they are. Now watch this. If I move that around, it always keeps the planes touching. Okay, that's all it does. Now I can show you another thing. I can mate this face to that face. Coincident again. And now I grab it, and it has only one way to move because it's been constrained in that plane and also that plane. So we have 2 coincident mates. Okay, I can show you another one. I can go this face to that face, and I'll go OK. Now that part is perfectly mated. Now let's say I'll show you another way you can do it. I'm going to delete these. You're going to have to open up these mates. You're going to delete the last 2. Just hit delete, and now look what happens. The part is free again, but it's still being constrained by those 2 faces. Now watch this. Mate. I'm going to get this inside hole and that inside hole, and look what it does. It knows they're not coincident, it knows they're concentric. The most common, the 99% of all mates are either going to be coincident or concentric. you're very rarely going to use. I don't think I've ever used a perpendicular mate in my entire life. I don't think I've ever used a tangent mate in my entire life. So the majority of them are either going to be coincident or concentric. I'll get into this last, a distance mate, now in a sec. Now watch this. I apply the mate, and I have a coincident and I have a concentric. Now watch this. I can grab this part, and it swings like it should. That's what it's like. There's only two mates on it, so I can either make this plane line up with that plane, but the proper thing to do is do another coincident mate, just like you would do it in real life. In real life, it's constrained by these coincident mates, which is a bolt going through them, and that's it. So I'll do it again nice and slow. I mate this face. Whoops a daisies, it looks like they're picking up something I had already pressed. That face with that face. Okay, that's done. This inside circle with that inside circle, and it automatically does a concentric. I hit the green arrow. This one. Now I could pick this, or I could actually pick this. Ah no. So let's try that again. I'll pick this inside. This tapered face is concentric with this hole, so it works. There you go. Now another thing is, if it's giving you grief, you can always flip things like that. I don't know that, you know what I mean, you'll see what I mean, you'll flip it around. Okay, there's that. Okay, now what's next? Insert components. I'll get the shaft and put that in, and the first mate will be that concentric face with that face, and look at it now. Okay. Now I've designed this in such a way that that face, if that face lines up, everything is going to be centered. But I'll show you a way. You might like this. So we want this thing to be centered. So I'll go mate, advanced mates, width. Okay, and what I'll do is I want the width selections. This from there to there, that's one set, and then the next set, the width selections, the tab selections. Now the other set is from there to there, and what it does is it just centers it right up. That's called a width mate. Now what happens here is if the distance from each of those brackets increases, this is still going to sit right in the center. It's just like a symmetric mate. Okay, I'll do mate. I'll get another. What am I doing? Before I need mate, I need to have another part. So let's get the caster. I just plonk it anywhere. Mate this cylinder with that cylinder, and let's do this. Look, we don't have to use that width mate if you don't like it, but you'd have to do the numbers. You'd have to measure from there to there, and there to there, and you would subtract the difference, and you could mate it that way. So I'll just show you again. Not advanced mates, we want mechanical. Advanced mates, not mechanical mates. Okay, so width. So I just need to pick the width are the widest ones. So that face will do, and that face will do, and then the tab selections are that face and that face, and it puts it in right bang in the center, like so. Now if I take a section view of this, you can see it's starting to look good, and it's starting to make sense, but we need the two bushings, or this thing is going to be a disaster of a caster. Disaster of a caster, I like it. Insert components, alright? We'll get the caster bushing. I'll hold down the pin so I can do multiple ones. There's one, there's two. Alright, I'm done with that. Okay, now watch this. Mate that surface with that inside there, concentric, and then mate that surface with that. Now that's going to be coincident. So watch this. This one with that, and I'm going to flip it. Oh yeah. We want it to be concentric, double check it, and then from that face to that face. Okay. And let's check it again, and that looks really nice. We have a pair of bushings there. You could sell that now. So the last thing we're missing are the hardware. So we have the base, we have all the parts, and I'm going to go insert components, and I'm going to go browse, and I'm going to get my flathead screws. I'm going to hit down the pin. I'm going to go 1, 2, 3, 4. Now, what's all this crap that's on those? That's sketch, extra sketch geometry that we really don't need. Now, you could open up that sketch, and you could turn the goggles off and look, I'll show you once. You could open up this part within here, and you can right click on that sketch, and you can just hide it. Now let's see, is that what's causing it? I don't think it is actually. Ah, it is, look at that. And we also have a plane, but what we can do is you can just go to View, Hide All Types, and it gets rid of all that extra stuff. It doesn't delete it, it just hides it. Now, these are a real model of a screw. That's basically what it looks like. Now, I need to find this. You're going to either pick this surface, or that surface is concentric, or that. This is usually the best one. Now I'll do it in one in each example. If I pick that surface, it's not going to work. There's no way that's going to work. That face is not concentric. So I'll go in and I'll get the main diameter. Okay. I'll flip it, and then I just go this face to that face. Now that screw head looks an awful lot bigger than that hole. Interesting. Let's open it up and check it. It's a countersink for a number 12 machine. How did I screw that up? So let's go back and change that to be, instead of size 12, let's change it to be size 1/4. Okay, so I'll save that. Now hold on a sec, I know I'm going very fast. How did I just open up that part very, very quickly? I clicked on it, I right click, and I went open part, and then I can just go back to the part level and make changes, and then it updates my assembly, and now that hole looks lovely. So I'll show you again. Mate, I can pick that concentric surface with that, and I flip it, and then I'm going to go that face with that face. Like so. Just drag that over there for a sec. That face with that, flip it, and then, so each screw needs 2 mates, okay, to get it in place. Yeah, granted they're going to rotate, but it doesn't matter. That's that screw settled. And then I'll even use this face right there, not the edge. Like I've just done, get rid of that edge. Face to face mates only. And that's that. Okay, insert component. Let's get the washer going. Hit down the pin 1 and 2 over there, and I'll go mate that face to that face. It automatically does a coincident, and from that face to any one of these. This will work, that will work, any of them will work. Okay, it does concentric, and then from that face to that face, and that face to that face. Now we're nearly done with the assembling. The last thing is we need the last of the 2 pan heads. 1, 2. Right, I'm just plonking that in and not doing a very job of explaining what's going on. Alright, just the normal mates. Hopefully you're getting the hang of it now. So that's coincident. I don't like it that way, I'll flip it. And then I'll go from that face to that face, just like it would be in real life. Okay? So there is the completed caster. Now, in this example, I wouldn't so much worry about material properties. I'm more interested in the, believe it or not, in the appearances. So, what I will do is I'm going to open up the. Now let's have a look and see what it looks like. I got a nice red, base. I have a rubber roller, and then the rest of it is steel. So let's see if I can do that. I'm going to open up the appearances, and look, if you want to do pick your own appearances, that's fine. Metal, plastic, metal, steel. Is there a red steel there? Any red? Nope. Let's go back to painted. Powder coat. Nope. Sprayed, red spray paint, car paint, gloss red. Let's just go with a red spray paint and put that on there, and we'll just do the caster base as red. We'll do rubber, matte rubber. I'm dragging this out, and I can either click on the face, I can click on the feature, the body, because the feature is basically the whole body, either one of those will work. Okay? Now at the moment I'm actually doing this at the assembly level. Now if I open up this part, it's black, so it is actually doing it at the part level as well, and that's good. Okay. And let's just do one more. Metal, steel, and we'll do a nice brush steel, and we'll do both of these brackets. Okay, and then let's do this. We want, the bushings are typically made of bronze, so can I find that? A nice brushed bronze. Now we're looking. That's a nice looking design. So I'll go File, Save As, and we'll call this Caster Assembly. Okay, we have that done. We have the assembly completed. So that wasn't too bad. Let me take a break for 5 minutes, and I'll get back and we'll do the rendering. We'll create an image now. The drawing is easy enough. We're going to create this nice rendering using something called Real View. So hopefully you have that installed on your computers, but I know we have it in the college. I'll see you in about 5 minutes. Hi, I'm back. There are some, it's not very common that we need to render objects. It's more a job of like an industrial designer or somebody who's involved with aesthetics or product design. A lot of the stuff we do in engineering is just like a case or a weldment or some sort of a machine, and really we don't really give a damn about. We you know, an isometric view is enough for us. We're lucky to get that. So we, most of the time in engineering, we really don't need a nice rendering. But you know, I have done it a couple of times in my career. So I'm going to just first of all, what is rendering? SolidWorks has a graphical engine that you can apply appearances to, and what it does is, using shading and lighting, it can create a very it gives you a very good indication of what the object is going to look like in the real world. Okay, so we have, let's have a look here. Let's open up our caster assembly. Now we're going to use a program called Real View. Now if I go to Tools and I go to Add-ins, Real View, it used to be called Real View, it's called Photo View 360 now. So I'm going to click on that and I'm going to go OK. Now what, these are add-ins that are not typically loaded by default because they all take memory. So I'm just going to open up Photo View 360, and then right quickly that pops up is a Render Tools. Now what you're going to do, try not to use this integrated preview. I'll show you what it does. I may as well show you both ways. Is that what it looks like? Is it? Well, I thought it would be better than that. I'm going to, oh no, there it goes. Now you're talking. So what it does is it uses your entire screen and it renders it. Now, if you don't move it around, the rendering gets better and better and better, like so. But if you constantly move this around, it needs to recalculate it. This is very, very slow, and I'm kind of glad you're seeing this. I'm going to turn this off, and what works a lot better is this preview window. And you can make this kind of small, that it doesn't have to there it is there. Let's make this nice and small. And as I move this around, it updates this window. And what I can do is I can move this window around and it will update this like so. Now if your computer is really slow, you can just pause this and do whatever you need to do here. Move it around, do whatever you need to do, and then go reset. Now, so this is what we're gonna get out. I'm going to minimize this or pause this for a second and open up my appearances. Now we have appearances and we have scenes. Now the scene is the background, and what I can do is I can just do, let's go to basic scenes, and we have 3-point beige. I'm going to drag this out and let's see what that looks like. Doesn't really change a whole lot here, but if I reset this, that's kind of nice there. I'm going to do the same. Let's get 3-point blue, drag it out here. Give it a second. Looks horrible. Let's do 3-point faded. You can experiment with this all you want. One thing that I like that seems to look good is ambient only, factory office space, warm kitchen, soft spotlight. I just drag it out here and it will update this. Okay, so you have different scenes. Presentation scene. You can play around with these all you want. So there it is. There, the scenes are the background, and the appearances change the material or the look of the object. Now, I'm going to go to options, and I don't know if you've ever seen the 240 by 240 image. It's a very, very small image, and if you make it big, it becomes very, very pixelated. 640 by 480 is better, and even better than that is 1000 by 1000. That's lots of pixels. Now, so the more pixels you have here, the longer it's going to take to render, but it's going to be a better quality. So if you have a very, very fast computer, it's going to be able to render it. You'll be able to put this up to 1000 by 1000. It'll render it pretty quickly. Now, the image format we want is a JPEG. And leave this the way it is, good and better. I wouldn't mess around with this, it'll be fine. Now, you could spend a lot of time playing around with rendering. You know, you could play with the decals, you could play with appearances, you could play with scenes. You spend a bit of time on it and see what you come up with. Excuse me. Okay, I'm going to go okay like that. And then I'm going to go, if I'm happy with what I see here, I'm going to go final render. Now, I haven't used this in a while, and I don't remember seeing all of this. This is new. So what it's doing is it's just rendering one at a time. It's I don't know. It's saying computing irradiance pre-pass. It doesn't matter. I don't care about any of this. Hopefully this won't take too long. I think what it's going to do now, once it's done with this pass, it's going to start rendering it. You'll see what I mean. It should be pretty quick. See, there it goes. So it can render this white space pretty quickly. I wonder, can I minimize that while it renders, and can I continue working? Yes, I can. I'm going to close this down now, and we don't need that. Can I close it down, or is it going to screw with my rendering? It probably will. No, that's doing its own thing there. Let's just minimize that. And it does significantly slow your machine down. I probably should just leave it alone. So it's going to output a JPEG. We're going to put that at the top right hand corner, and then I need to show you how to do an exploded assembly with a bill of materials. And then we have this. So let's just see, is this thing nearly done? That's it. I'm going to turn off the video for a sec, and then we'll have the image ready to go. So I'm just turn. So I'm back. So we have this nice rendering of our caster, and there it is. It's just an image. You know, it didn't take a whole lot of effort, and it is quite realistic. One thing I would have changed probably is before we did it, I would have right-click here, and I would have turned on perspective. Now what it does is it's more of a, as the object goes away from you, it gets smaller. That's how it is in real life. Turn on your perspective when you want to render, okay? And then when you're doing your normal modeling, you know, get back to what is the opposite of orthogonal, okay? So I would have turned this perspective on, and it probably looks a little bit better. Now, I wanted to show you some examples. This is just it's a mouse. Here's an engine hoist, a bottle with liquid in it, the threads, plastics. So it's, you know, the rendering is kind of cool. It's pretty, and it, you know, I don't know where else I would have used it. I'm looking at Jantech here. I don't think I did a whole lot of rendering working for them. Anyway, so it's not a bad little skill to have. It's not that difficult. The trick is going to tools, add-ins, turn it on, and then you have access to render tools, and you can I don't like integrated preview. Use the preview window, and you can play around with the appearances, play around with the scenes, and you can come up with nice, you can do it whatever way you want. You can come up with nice images. Now, so once it's done, you can save the image, and we'll save it in our caster project directory. Everything goes in there, and we'll call it caster render 1, and that's it. I'll close it down, I'll close this down, and I'll close this down, and it's time to, well, before we create a drawing, I have to create an exploded assembly, so let's just do that. So let's open up the caster assembly. Now, exploded assemblies are for people who have to, they're for the people who have to assemble this object. It gives them a clear indication of what parts are required, what parts are needed, and how they all fit together. Like, this is a pretty simple example. Let me show you some other exploded assemblies. There you go. Now that's a lot more complicated. I can see here that this connector needs 4 washers, 4 bolts. This connector needs an O-ring. This board has, I don't know, 15 screws. The lid has 5 screws, and so on. You know, so when I worked for this company, all I did was exploded assemblies. I don't know if I have any other ones. There's another one there, a lovely exploded assembly of a part, or an assembly. So, how do we do it? You've never played around with these tabs, but we go into the third one, the configurations. I right click here, and I go new exploded view, and this opens up. I'll show you again. You're used to working in the feature tree. We come over to the first, second, the third tab. I right click on this, and I go new exploded view. Okay? And what I'm going to do is I'm going to click on this object, and I'm going to drag it down like so, and then I click somewhere else. Then I'm going to click here, click there, click all of these, and I have this as a group, and then I drag it away, and then I don't hit the green arrow, click somewhere else, and I rotate, and I get all of these again, and I pull them out. If you click the wrong one, click on it. The other thing you can do, you can actually highlight it here if needs be, and drag it out. See, I'm after getting the wrong one right there. So that's okay. And I actually got the shaft as well. So come on now. Pull this. Oh my god. So you can see I'm really screwing this up. I'm going to delete that step and delete that step and then go back on the left hand side. Now I have a feeling this is going to screw with some people, and you're just going to have to play around with it. Come on now. There you go. Okay, I got that. Probably don't need it as far away as that, but that will do. And then I have the bushing and the shaft. Jesus, I shouldn't be saying that. There we go, finally. Let's delete that exploded step on the left, and let's just try and get one bushing. The issue with this is you tend to select other objects that you don't want to pull away. And then I have that, and I'll bring them up. I like that, looks good. And then this comes out. And you're just pulling this stuff apart. You're not deleting any mates or doing anything. You'll see what I mean now in a sec. I'm doing a lot of revolving and moving around the place. Now, this is going to be my camera view. That's the view that I like. So I'm going to pull this up, and then I'm going to pull them out. I probably could have done that in one step. Like so, that's it. I'm going to go OK. Now you can delete any of these steps here, or you can modify them. You can do whatever you want. I have a feeling you're going to have to play around with that for a while. When I first started doing SolidWorks, I really found exploded assemblies frustrating. That just how it was set up. You're going to have to play around with it. Okay. Now that's it. So we have a caster, and then that caster has its own exploded view. Now watch this. I can right click and go collapse, or I can right click and go explode. I can right click and go animate collapse, and it just shows you how to put it all together. You could save this and create a video if you want, an AVI, or I can right click, I can go animate explode, and it just shows you how it's pulled apart, whichever way you like. Okay, save this and put it up on YouTube if you want to. Now, so we have that. Now, let's say, well, where's my assembly gone? Let's go back. Let's right click and we go collapse. So this assembly has two configurations. It has the collapsed configuration, and it has the exploded configuration. Now, what I typically do is I'll collapse it and I'll save it. Now watch this. I'm going to go File, I'm going to go New, and I'm going to go, I need to tell, where is my template? Do I have a template in here somewhere? I'm going to have to find the template. I just made one there a while back. Where did I put it? In Advanced Drawings, Templates. Okay, there it is there. AACC, where was it? I had a template that I had shown you in the video, and now I don't have it anymore. So what am I going to do? You're going to use your own template, and I'm going to just have to use the normal SolidWorks template for a bit. I'm going to go File, New, and that kind of sucks. Let me see if I can figure this out real quick. just bear with me for a sec. I'll just use this one here then. So I need to tell it where my templates is. Options, file locations, add, and I'll go AACC. I'll go 260. I'll go lectures, and I'll go, it's in archive. No, it's not. Drawings, templates. Okay, I'll go new. I got this one here, okay. You're going to use the template that you have. You're not going to be an idiot like me and lose it. So this is an 11 by 17, or this is an 8.5 by 11 template. Now see if I can, is there anything I can do with can I change this sheet and edit the sheet? Edit sheet format. Can I go to properties and change this to be ANSI B? Yeah, there you go. It's not really what I want. Let me just see where we are in this drawing. Let's have a look. Yeah, I'm gonna just use this. I'm wasting enough of your time. There we go. All right, you're going to have your own template here. Now let's have a look at the drawing. Okay, here at the front we have the exploded assembly and we have the rendering. This looks a little bit different. So the first thing we want to do is let's put in the rendering. So I'll go insert, picture, and it comes straight to my caster project. I'll insert that rendering at the top right hand corner. Like so. And then I'm going to go model view, browse, and I'm going to find my assembly, my caster assembly. Now let's have a look. If I turn on preview, you can see there that it wants to do the assembly in it. It's not bad. What I need to do is first of all I want an isometric, and then if I drop this down I should be able to show it in the exploded state. And it doesn't do it. Aha, it does. I have to click there. Okay, let me do that again. Alright, I go model view, browse, caster assembly. I can do isometric, show and exploded view, and it does nothing, but if I click there it does, it breaks it up. Now that doesn't look too bad. I'm going to click on the view and I'm going to make it hit the color first thing, and then I'm going to make this 1:1, too big, and then I'm going to user define. I'm going to try 1 to 1.5, a little bit too small, 1.25. That looks good there now, but let's make this view, this image, a little bit smaller and give me room for this, like so. Now each part's origin is showing, so we'll go to view and we'll hide all types, and it just gets rid of extra information. So unfortunately this title block isn't exactly the way I want it to be. I have my exploded assembly, I have my view, my rendering. The next thing I need to do is get this bill of materials. So I'll go insert, tables, bill of materials, and I'll click on this assembly. Now don't worry about this. I've been using SolidWorks for about 10 years now and I don't pay any attention. I just go OK, and what does it do? It gives me the item number, the part number, and the quantity. and I'll grab this and I'll move this down there like that. What I actually have to do is I'm actually going to move it up a little bit because we have this watermark that comes in. So if you move this down below, that watermark is going to interfere with it. So just move it up slightly. We have the bill of materials. This tells us what each of those parts is. And the last thing we need to do is go insert, balloon, insert, annotations, balloon. And all I'm going to do is I'm just going to click on that. I'm just lining up these balloons, keep them nice and neat. And it's kind of nice if you can group them together as well. Just don't throw them anywhere. I'm just clicking away here, that's all I'm doing. Just left clicking the whole time. Now what do these balloons do? They just tell a person who's reading your drawing that this washer is part number 7. If I go to part number 7, there's the part number and there's 2 of them. Now a good engineer will know that this is a McMaster car number. What you can do is you can double click on this and it says here, it's basically saying that this number is linked to that part. If you change the part or you do something to the part or you swap the part out, this number will be automatically updated. Now if you manually break that link, it's not going to automatically update it. Now this is fine, so just go yes and then put in the square brackets Mac Master and then double click, just go yes, don't worry about that warning, Mac Master. And that tells a newbie that these parts are all McMaster car parts. Okay, so what do we have? A bill of materials table. You get it from insert, tables, bill of materials. These are called balloons. We have a rendering, we've exploded assembly. Now I'd like you to do 2 sheets. Now I should have done this before we started, but watch this. I click on the sheet, I go Control C, Control V, and it says, right, if you want to copy this entire sheet, you can either put it before or you can put it after, you can move it to the end. And I'll just go after. And look what it does. It creates 2 of them. So go to sheet 2 and delete all of this. Don't worry. And now you have sheet 1 and you have sheet 2. Now I should have done that at the very start. Okay, I'll right click here, I'll go rename, and we'll call this sheet 2. So we have one file, one drawing file, but one drawing file can have multiple sheets. Now what do we want to do in here? Sheet 2 is going to have all of this, and I want this drawing, this sheet number 2, to be identical to this. Identical dimensions, and I want you to have labels on it. Okay, now that's it. I hope I haven't gone too fast. I'll see you later.